So the first type of challenges, without surprise, as you know, hydrogen is a very small molecule and it could permeate any types of material. So polymers and metals. So without surprise, this is creating a lot of sealing issues. And in a wide variety of equipments like compressors, like refueling stations, you have very, very high pressure. So there will be some RGD issues that we will have to solve. And this material, as you will see, is a nice candidate to solve these type of issues. Moving to Arnold 3000 XT now. So there are several challenges that are related to more specific equipment. So the sealing issues, you will find them everywhere, almost everywhere. You know, as long as you have some sealing elements in your device, there will be some issues like that. Here it's a little bit more specific. So if you look at control valve or pressure relief valve, you will face extreme pressure. And some components like the valve seats could really face some problems like material deformation. In reciprocating compressors, you have to use non-lubricated compressors because you need to avoid to poison the fuel cell at the end of the supply chain. So that's one issue. And on top of that, the hydrogen molecule has very low lubricity. So this is creating a lot of wear and friction issues, especially with the components like the piston rings, the rider bands. In electrolyzers, there are two types of problems here. The first one is aggressive media. I will speak about that in the next slide. And you need to make sure that all the materials you will be selecting in your electrolyzers will be suitable with the various media that you will find. And also the temperature. If you look at the industry trends, there is a need for higher temperature to increase the efficiency of the electrolyzers. And by doing this, the problem is that you're reaching the limit of the majority of the materials that are currently being used in electrolyzers. So what you will see here is a degradation of mechanical properties of some components like the frame, for instance. And that's another problem that we need to solve here. And finally, with the fuel cell, more specifically with these compression end plates, you have very, very high compressive loads that is being seen by this part, meaning that you have a lot of material stress and deformation that are applied to the end plates.